Okay, so in this video we are going to simplify radicals. So a radical is like a square root. Okay, so let's go over that first. So when we're talking about radicals, we're talking about like the square root of 25. I'll just put that in there. Okay, so this is called the radical sign. This is the radicand. Okay. Okay, so, and then any expression that has a square root sign in is called a radical expression. So I guess we can say this whole thing is a radical expression. Okay, so it can look just like square root 25. We've done that a million times, it's 5. It could be irrational, like the square root of 27, or it could be the product of an integer and the square root, so like 2 square roots of 5, let's just say. Or you could have variables in here, and your TEAC says that you just have to do these with numericals, so just numbers, which is going to make it pretty straightforward. But you could have like the square root of 25x, that could be a thing. Or you could have like x square root of 3 or something like that. You won't see those this year. You'll see those in Algebra 2, and sometimes it comes up in geometry a little bit. Alright, so the title here would be Simplifying Radicals. Simplify radicals, and this is a section in your book, but I think they go into, if I remember correctly, they're going to go into variables, which you don't need to know at this point. So we're just going to do this quick and get to the main point of what we need. I'm just paging through the book really quickly. And yes, they have variables all over the place, but that's not what your TEAC says, so we're not going to go there yet. Okay, so simplifying radicals. So a radical expression is simplified when expression is simplified when. So you need a couple of things to happen. First of all, you can't have any perfect square numbers underneath the radical sign. Okay, so number 1, the radicand it has no perfect square. Perfect squares. Like 4, 9, 16, 25, those numbers, right? No perfect square factors, other than 1, of course, because 1 is a perfect square, but that's okay. Square factors other than 1. Running out of room. There we go. Okay, that is, in my opinion, one of the most important things, and that's really what we're going to work on. The other thing is you can't have fractions underneath there. You have to like kind of pull them out, so to speak. So the next one would be, I'll use red for letter. Red and blue. Okay, so the radicand is not a fraction. And I'll show you what I mean and how to pull it out, so to speak. So not a fraction. We don't want fractions in there. Everybody has things against fractions. Okay. And then the very last thing is there can be no radicals in the denominator. No radicals in the denominator if it's going to be truly simplified. Denominator. Sorry. Alright, so we need to look at 2 different properties of square roots to help us take care of all of these things. The first one is a multiplication property. So multiplication multiplication, property of square roots. Okay, and that just says that if I have square root of a times b, I can split that up into the square root of a times the square root of b. Okay, and then of course, as long as a and b are greater than or equal to 0, it has to be greater than or equal to 0, because we're not going to do negative numbers. You can take the square root of a negative number, but it's not a real number. It's imaginary, and that's like pre-cal, I think, is when you first start talking about that. Okay, so, for example, let me see. If I have the square root of, say, 100, wait, well, you already know what that is. I'm sorry, a times b. So I have the square root of 4 times 25. That's the same thing as the square root of 4 times the square root of 25. The square root of 4 is 2. The square root of 25 is 5. So that gives me 10, which we know, since we know that that's the square root of 100. Okay, so just showing you that you can split up the radicand into factors, and that's going to help us simplify them, because what we're going to end up doing is taking out those perfect square factors. Okay, the next property is the division property. So division property of square roots. And that says that if I have the square root of a over b, that is the same thing as the square root of a over the square root of b. And that's how we're going to pull the fractions out of the radicand. Okay, here's the thing. Sorry, I can't see the rest of these notes. I think it's, you can't have a radical sign in the denominator. Okay, so you're just not going to leave that there. Okay, and I'll show you how we're going to get rid of that in a little bit. Okay, so let's see how we simplify these. Okay, so if I have, for example, so let's just do some examples, the square root of 32. I need to split that up. So what I'm going to end up doing is sort of like a prime factorization. Okay, so you can split these up into all of their primes, or you may be able to see, oh wait, there's a perfect square in there somewhere. Okay, so let me first go to do it all the way down to primes, because if you're stuck or you're not sure, that's what you're going to do. Kind of like when we did exponents, expand it all the way up. Okay, alright, so if I look at 32 and I do like prime factorization like you did in, I don't know, 5th or 6th grade, 32, the first thing I think of is 4 times 8. And then I'm like, oh, 4 is 2 times 2. And that's as far down for primes as you can go. Other than 2 times 1, but that doesn't really matter. Okay. And then 8 is 4 times 2. Oh, but 4 is 2 times 2. Then, you, I believe, went through and circled, these are your prime factors. Yes? So, I'm going to write 32 with those prime factors, but I'm not going to use exponents. So the square root of 32 is 2 times 2 times 2 times 2, that's those 2, times 2. Okay, so here's the deal. When you do a square root, you need to take these factors out in pairs of 2. Since it's a number multiplied by itself is the square root, right? The square root of 25 is 5, because 5 times 5 is 25. So in order for them to come out of the radical sign, they have to come out in pairs. Okay. Someone once told me that he remembered that because it takes 2 to break out of jail. Not sure if that's going to help you, but hey, whatever works. Okay, so I pairs of 2 here, and they come out. Here's another pair of 2, and it comes out. Now, when it comes out, it gets multiplied. So these 2's came out. Oh, let me do this. So because this was not a good example. There's like a ton of 2's everywhere. Okay, 2, and then I circled these 2, and they came out. So times 2, and then this guy's lonely. He can't break out, so he just stays under the radical sign. Okay, 2 times 2 is 4. So 4 square roots of 2 is simplified. Okay, now here's the deal. Yortik says that it's numerical. What can you do with numbers? You can put them in your calculator. Yay! So you could just do square root of 32 on your calculator, evaluate all your answer choices, and find the one that gives you the same decimal. Okay, but you do need this skill. You need to know how to do this for Algebra 2, Geometry, Pre-Cal, etc. Okay, all right, so I'm going to show you the other way you do this, because I don't always do that. The other way is if you have the square root of 32, and you said, oh, well, that's equal to the square root of 4 times 8. Okay, but there's still a perfect square there in 8, which is equal to 4, and 8 is 4 times 2. Okay, and now I'm like, oh, the square root of 4, which is equal to, this is kind of what goes on in my head. I don't always write it all down. Now from here you can say, well, you have 2 4's, bring them out. Bring it out as a 4, that's fine. That works too, just like we said. The square root of 4 is 2. The square root of 4 is 2. The square root of 2 is some irrational number, 1.414. So I have 4 square roots of 2. Okay? So some of you might look for perfect squares. Some of you might say, why didn't you just do 16 times 2? Yep, that works too. So there's a couple different ways you could go with it. If you can't think of any perfect squares in the number, break it down to its prime factorization. Okay, so let's try another one. What about, let's see, the square root of 72. Let's try that one. The square root of 72. Well, the first thing I see in 72 myself is 9 times 8. 9 is a perfect square, so that's good. 8, though, has a perfect square in it because it's 4 times 2. So I'm going to write that as the square root of 9 times 4 times 2. And I got a little crazy there. There we go. And then I'm going to split it up by my property of multiplication. Square root of 9 times square root of 4 times the square root of 2. And the square root of 9 is 3. Square root of 4 is 2. Square root of 2 stays inside. So I have 6 square roots of 2. Okay. All right. Let's try one more. Let's try the square root of 160. Let's see what that is. Well, the first thing I see is 100 times 60. And 60, let's see, 6 times 10. So this is what I'm thinking with 60. This times 10, and this is 3 times 2, and this is 2 times 5. Oh, so 4 times 16. That's a perfect square. Times 15. I think I said 16. I so meant 15. Okay, and then that's all my perfect squares. So it's the square root of 100, and 60 is 4 times 15. So the square root of 100 times the square root of 4 times the square root of 15 will give me 10 times 2 times the square root of 15, which is 20. And I always say 20 square roots of 15, but usually you'll hear them say 20 root 15. But I see that I have 20 square roots of 15. I look at that square root sign almost like a variable, like 20x would be 20 x's. So that's why I say it that way. Okay, and again, totally could grab your calculator, do square root of 160. do all your answer choices and find the one that is the same decimal approximation. Okay, so what about radicals in the denominator? Okay, so it might be one of the things they changed in math, that it doesn't matter. Someone, I think, told me that once, but it does. You can't have radical signs in the denominator. It's just not right. So you're going to do what's called rationalize the denominator. So for example, had the square root of, say, 3/5. Okay, so I split that up. Square root of 3 over the square root of 5. And I'm done. That both of those are irrational. They're not perfect squares, but I can't do that. So in order to get rid of the square root, you need to multiply it by a square root. Okay, so let's look at this. If I'm trying to think how to explain this. If I have x squared equals 25, right? You do the square root, you do the square root. So the square root undoes the squaring. Okay, so that's, you need to know that. Square root undoes the squaring. Therefore, if I square a square root, I'm going to get the square root of 25 times the square root of 25, right? That's what squaring means. Well, that is the same as 5 times 5, which is 25. Okay? So, if I multiply this by the square root of 5 over the square root of 5, I'm going to get the square root of 3 times 5. Like I'm using your multiplication property backwards, putting them back in, over the square root of 25, which is, let me erase this here quick so it doesn't all run together, which is the square root of 15 over 5. Okay, so these things here, these are equivalent, but this one is simplified. Okay, let's do another one. Let me see, what if I had the square root, oh, red, okay, 9/2. Well, that's the same thing as the square root of 9 over the square root of 2. And the square root of 9 is 3, but the square root of 2 is irrational. So we're going to multiply it by square root of 2 over 2, because anything divided by itself like this is still equal to 1. So all I'm really doing is multiplying by 1, which doesn't change the value at all. Okay? So 3 square roots of 2, 3 roots of 2 over the square root of 4. 2 times 2 is 4, so square root of 2 over 2. Okay? So you can go right from here to here. Okay, if you know that, as long as I'm multiplying by the same radical in the denominator, it's going to cancel it out, so to speak. Okay, and then that's because square root of 2 times the square root of 2 is the square root of 4, which is 2. Because squaring and square root are inverse operations, like addition, subtraction, multiplication, division. You have taking the square root and squaring. Okay? Alright, so let me think of one more example. Oh, sometimes you have do one where, like say we have the square root of 81 over 4. So that is the square root of 81 over the square root of 4, which is 9 over 2, and there's no rationalizing the denominator, because sometimes it does actually work out. Okay? Again, you get a calculator. These are all supposed to be numerical. And I have not seen any division problems on any of the release tests. They're usually just like the square root of a composite number that has perfect squares in it. So you should be fine. But we need to know how to do it, obviously, because we need to know how to do it next year. Okay? Alrighty.